let's cover integration by parts. So let's consider the below integral, and we have the integral of x multiplied by sine x, and we need to integrate with respect to x. So thus far we have solved integrals using functions and their derivatives, as well as the substitution rule. However, I want you to try and solve the above integral using those methods. Okay, I just want you to use functions and their derivatives and check if the substitution rule works. Try and integrate that. And you'll see that the above integral cannot be solved using only these methods. Hence, we are going to use a new method known as integration by parts to solve this indefinite integral. Now, before we actually start using the method of integration by parts, let's firstly let's work on identification. That is, when do we need to use integration by parts? How do we recognize that a specific integral should be integrated using by parts? So when are we required to use by parts? In most cases, try using integration by parts when, and this is a general rule, we have two or more different types of math functions that are being multiplied by each other. So notice that most of the mathematical functions that you have encountered in your studies, they can be classified using this following acronym. And the acronym is called LI8. So what does it stand for? The L means logarithms. The I means inverse trigonometric functions, so your arcsine, arc, cosine, arctangent. A is the algebraic functions. T are your trigonometric functions. E are your exponential functions. So remember, your exponential functions are stuff where you have e to the x, you have 2 to the power x, where the x variable is in the exponent. Your algebraic functions are basically almost, or the most common types of functions that you would have encountered. So stuff like x squared, x cubed minus 5x, the square root of x, for example. So when you have two different types of math functions, and this is a general rule, there are also certain instances where you have maybe an algebraic multiplied by an algebraic, and then you can use by parts. So again, this is a general rule. It's not a hard and fast rule. So in general, when you have two different types of math functions, for example, in the previous slide, I gave you x, which is algebraic, and that was multiplied by sine of x, which is trigonometric. That's a hint or a clue that you have algebraic times trigonometric. You should look at using by parts to integrate this function here. So the technique or rule for integration by parts is given by the following formula. So here's your integral, and your integral is going to be of the form f of x multiplied by g prime of x. Don't worry about the g prime and what the f is right now. I'll explain it in the next slide. Basically, you have one function multiplied by another function, and then your integral is going to be of the form, the first function as is, then you'll multiply it by g of x, so you'll have to integrate that g prime function, and then you'll subtract, and you're going to have another integral here. You're going to subtract f prime multiplied by g. Okay, so it looks complicated, but when I show you what to actually do and how to identify it, it's going to be super, super easy. So the most important step in integration by parts is choosing f of x and g prime of x, because this here is your question. Usually you're going to have two functions. Okay, I say usually because again, you can have 3 functions, 4 functions, you can have any number of functions multiplied by each other. But to show you by parts, I'm just going to use 2 functions. So your 2 functions are going to be x. So let's use the previous example. We had x multiplied by sine of x. What you are going to have to do is choose which one is going to be an f function and which one is going to be the g prime function. So this one could be f and this one could be g prime, or this one could be g prime and the sine x could be the f function. So that's the most important step in by parts, choosing which function is going to be the f function and which function is going to be the g prime function. And to help with this choice, we are going to use the LI8 acronym. There's a reason why I taught you that. And the best way to show how to use it and to do by parts is to obviously do an example. So exercise 1, solve the following integral. You have the integral of x multiplied by sine x. If you want to try it on your own, pause the video, but since it's the first example, I'm going to walk you through this one. All right, let's do this. So let's identify what we have. We have the integral of x multiplied by sine of x. Now, I know that x is an algebraic function and sine of x is a trigonometric function. So this means I have two different types of math, and I use that word or that phrase in inverted commas. Okay, two different types of math being multiplied by each other. I have algebraic multiplied by trigonometric. This suggests that I should use by parts. Now, when I'm using by parts, I always use the acronym LI8. Logarithms, inverse trig, algebraic, trigonometric, and exponential. Now, how does LI8 work? LI8, the acronym, is a tool that gives us in general, gives us what function we should choose as f. So we have logarithms. Do we have logarithms in this integral? No, we don't. Do we have inverse trig in this integral? No, we don't. Do we have algebraic in this integral? Yes, we do. What is the algebraic function? That is x. So the first function that appears in the LI8 acronym, that is going to be the f of x function. So f of x is equal to x. That would mean that g prime of x is equal to sine of x. There we go. That's how LI8 works. It identifies, so the first function that appears from the LI8 acronym is going to be the f function. It identifies what the f of x function is. Okay, the next thing that we need to do by parts is we are going to look at this f function and we are going to differentiate it. So you'll get f prime x, differentiate x, that's going to be 1. Next, we need to get g of x. So we are going to have to integrate this sine function. If you integrate sine, it is going to be negative cosine of x. All right, and now we have all we need. Now, this integral is going to be equal to, remember the formula for integration by parts. Okay, go back in the video, take it down if you didn't copy it, and look at it carefully. This integral here is going to be f multiplied by g, so that is going to be x multiplied by negative cosine of x, so that will become negative x cosine of x. Then we have minus the integral of f prime multiplied by g of x. So it's 1 times by minus cosine x, so we have the integral of minus cosine x dx. And now we just need to solve this. In other words, basically solve this integral. That's what by parts usually does. We are taking a complex integral, okay, something that is a bit more complex, and we're going to simplify it. And hopefully, if we do by parts right, and we identify our f and g prime correctly, the resulting integral that we get, yes, we do get a resulting integral. It's some work to do, but this integral here, should be easier to integrate than that integral that we started with. That's how you know you're applying by parts correctly. So let's complete this question. This will become, let's not touch that, we don't need to do anything there, minus x multiplied by cosine of x, minus times a minus, that becomes plus the integral of cosine of x dx, and now we just can integrate the cosine, so we'll have minus x multiplied by cosine of x. What's the integral of cosine? It's sine, so it's plus sine x, and don't forget the constant of integration. You can add that at the very end. And that is how you perform by parts. Okay, use LI8, identify f and g prime, and then you're just going to apply the formula. And if you don't want to look at the formula, this is how I remember to get to this second step here after I have my prerequisites. So in the beginning, we had f multiplied by g prime, right? That was the integral given. Then the first answer is going to be f multiplied by g of x, so you have to remember that. And then the last step is the integral of f prime times g of x. So f times g prime, that was in the question. And then my last integral here is going to be the opposite, f prime times by g of x. And then you'll have to remember f of x times by g of x. Okay, in other words, it makes the shape of an S. okay, when you have it in this format here. Okay, exercise 2, solve the following integral. You can see obviously we need to use by parts, so pause the video and try it. Okay, let's do this. So how do I know that I need to use by parts? Firstly, we have two functions multiplied by each other. We have x multiplied by cosine of x. X is algebraic. Cosine of x, that's trigonometric. So I have two different types of math being multiplied by each other. That's a hint or suggestion that I should be using by parts. When I think about by parts, I think about LIATE. Why? LIATE is a tool, it's an acronym that gives us the f function. All right. So look at this integral. Do I have logarithmic? No. Do I have inverse trig? No. Do I have algebraic? Yes, I do. My algebraic function is x. So since the first function I have is algebraic from this LIATE acronym, that algebraic function is going to be my f. So f of x is going to be equal to x. That means that g prime of x is going to be equal to cosine of x. Now we can continue with my prerequisites. So I have f of x. Now I need f prime of x. Differentiate x, that gives me 1. Then I have g prime of x. I need g of x. So I'm going to have to integrate cosine of x. The integral of cosine of x is sine of x. There we go. That's my prerequisites done. All right, now let's use integration by parts. So if you want to use the formula, go ahead. I don't want to memorize the formula, so this is what I do. In my original integral, we had g prime multiplied by f, or you can say f multiplied by g prime. Order doesn't matter. Then my answer is going to be f times g, so that's x multiplied by sine of x, and let's complete the s. Then my other integral is going to be minus, so it's going to be 1 multiplied by sine of x, so it's going to be minus sine of x, and integrate with respect to dx. Let's solve this. It's x times sine of x. Then the integral of sine of x. The integral of sine of x, be careful with this, that's minus cosine of x. Why am I saying be careful? Because you now have a double negative. Okay, so you have a double negative, you need to take care of that, and let's not forget the plus c. So the answer is going to be x times sine of x plus cosine of x plus c. And that's how you handle by parts.